All right. Well, hello, Honors Algebra 2. You have made it to the last required lesson of the year. So, as a reminder, next week I'm going to be posting some Unit 12 materials, which will basically just be some additional stuff for trigonometry that will be helpful next year. So, if you're wanting to kind of see some additional things just to get yourself as ready for next year as possible, I'm going to be uploading those for you next Monday. Otherwise, this is it. This will be the last thing covered on the final exam. So if you've made it this far, kudos to you. Thank you for working hard. And make sure, guys, if you've got any questions on anything, to let me know. So that being said, let's get into it. So 11.11, frequency distributions. So starting off with, we have our general addition rule. As a reminder, we saw this in the previous lesson 11.10, which was that if you want to find the probability of A or B, you can find that by taking the probability of A plus the probability of B minus the probability of A and B. And then what if the events are mutually exclusive? Well, remember, to be mutually exclusive, that means that the probability of A and B would be 0. That just means that then you can take the probability of A plus the probability of B, and you don't have to subtract anything off. I don't know that we had a chance to use this in the previous lesson, so today we'll for sure get to use it so you can kind of see how this works. Now, we're going to do that in the context of frequency tables, or frequency distributions. We're going to see kind of a few different examples of that. We're going to see what are called two-way tables. We're going to see what are called Venn diagrams, which you've probably seen before. And we're also going to see these in the context of tree diagrams. Okay, so first example. What is the relationship between educational achievement and home ownership? A random sample of 500 people who participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate or not, and a homeowner or not. Overall, 340 were homeowners, 310 were high school graduates, and 221 were both homeowners and high school graduates. So we're going to create a two-way table that displays the data. So when you create a two-way table, most of the ones that we are going to deal with are going to be 3 by 3, although they can be a little bit bigger depending on the scenario you're working in. Now, as you make this table, the last row and last column are what are called the marginal probabilities. Now, we call them marginal because they're in the margin of the table, but another way to think about those are as your totals. So here's where you kind of would add everything up. Now, there were two different categories that they separated these people into. One was whether they were homeowners or not. So I'm going to call that H, and then not homeowners. I'm just going to call that H complement using that notation that we saw in the previous lesson. And then it told us that we also had some that were high school graduates and not. So again, I'm going to call those graduates and graduates complement. Okay, so first off, first piece of information we were given was that there were 500 people total that took part in this survey. It said that each member was then identified, and overall we had 340 who were homeowners. So our total for the homeowners would be 340. It also tells us that 310 were high school graduates, so that would mean that 310 would be our total for high school graduates, and then 221 were both homeowners and high school graduates. So both homeowners and high school graduates would be that top left part of the table, so that would be 221. Now notice that that only gives you parts of the table, so it's up to you to kind of fill in the rest. And you can just do that by doing some pretty quick subtraction, trying to figure out, 221 plus what gives you 340, and the answer there is 119. 340 to get to 500 is 160, and you can kind of just start to fill your table in all the way around. So let's see, this would have to be 71, and then this would have to be 89. Okay, so let's find some probabilities now using that. So suppose we chose a member of the sample at random. Find the probability that the member in part B is a high school graduate. So we want, what is the probability that they're a high school graduate? Well, there were 340 high school graduates out of a total of 500. So take 340 divided by 500, 0.68 would be your probability. In fact, really both of these would be correct. So when it comes to taking the quiz or when it comes to taking the final, just be sure you know which one I'm asking for. There might be some times where I say leave it as a fraction. There might be some other times where I say write it as a decimal. So be very careful knowing which way I'd want you to write it. Okay, for C, that they are a high school graduate and own a home. So what is the probability of being a high school graduate and a homeowner? So I guess home and high school graduate would be this. So to find that out, homeowner and high school graduate, that would be this 221 out of the total of 500, which is a decimal, would be 0.442. Okay, D is going to be the first place where we get to use our general addition rule for the first time. So we want to know what is the probability that they're a high school graduate or that they own a home. So you can either use the symbol there, I'll just go ahead and write out, or own a home. So using our formula, then what we're going to do is we're going to find what is the probability that they're a graduate plus what is the probability that they're a homeowner minus the probability that they're a graduate and a homeowner. Which here's kind of the convenient part about the way that these questions are set up, and this is just something that I do anyways, is you've already actually found 2 out of those 3 probabilities. Graduate and homeowner was part C, that was the 0.442. Homeowner, we already found in part B, that was the 0.68. So really the only probability that you don't have yet is the probability that they're a graduate, which was the 310 out of 500. So convert that to a decimal first, which I believe should get you 0.62 plus 0.68 minus 0.442. Tells you that there's a 0.858, so 0.858 probability that they're a graduate or a homeowner. Okay, let's take a look at another example. So according to the National Center for Health Statistics, in December 2012, 60% of U.S. households had a traditional landline telephone, 89% had cell phones, and 51% had both. Suppose we randomly select a household in December 2012. We're going to first make a two-way table and then make a Venn diagram so we can compare the similarities and differences. So, in making our two-way table first, remember we'll start with that 3x3 grid. Remember that the last column, last row are for the totals. Now in this case, we're going to have 2 different variables that we're looking at. We're going to have landline phones and those that didn't have landline phones, as well as cell phones and those that did not have cell phones. So as we fill these in, it says that 60% of U.S. households had a traditional landline phone. So that would be 0.6 that we'd fill in for the total for landline phones. So notice that this time, instead of having the actual number in the sample, we have a percentage. When you have the percentage instead of the actual number in the sample, we just call it a relative frequency two-way table. And that's going to be something that comes up on the homework a few times. So when you see relative frequency, know that it wants you to give the actual proportion or percentage rather than the actual count and number. Okay, so that being said, let's look at some other ones. 89% had cell phones, so that would be 0.89 as total for cell phones, and 51% had both. Okay. So I guess we can fill in some more of these, like this would have to be 0.09 to add up to be 60. This would have to be 0.38 to add up to be 89. But then we can have a problem. If you notice, we can't really fill anything out based on the information that they gave us. However, let's think about the total of the totals. Let's think about the overall total. When you're thinking about percentages, all percentages have to add up to be 100%, or as a decimal, have to add up to 1. And then once you've got that filled in, you can go ahead and fill in the rest of this table, and we should be good to go. Okay, so now let's do the same thing. Let's create another display, but this time with a Venn diagram. So with our Venn diagram, you're going to put a large box, then you've got your 2 circles. One will be for landlines, one will be for cell phones. So when you think about where they share, where they overlap, so the people that had both landlines and cell phones, that's this 0.51. That's going to go in the middle of both of these. So that's the shared or overlapping region. So then what we want to go right here is we want the people that had landlines but that didn't have cell phones. So landlines but no cell phones would be this 0.09. And then we'll do the same thing for cell phones. We want for what are the people that had cell phones but didn't have landlines. So go into the table, cell phones and no landlines was 0.38. Now, there's one more probability that we need to find, which is one that we're not always used to finding, which is what about the people that didn't have landlines and didn't have cell phones, which is this remaining 0.02. So if you notice, now looking at our table compared to our Venn diagram, you can see that to go from the two-way table to the Venn diagram, you just use the probabilities in the top left. You do not include the totals at all. So now let's use those to find some probabilities. Let's find the probability that the household has at least one of the two types of phones. Well, we can do that a few different ways. Probably the easiest way is to use the complement rule. Let's just find 1 minus the probability that they don't have either of the two types of phones. And 1 minus 0.02 is 0.98. The other thing you could do is just add everything else up, and you should get the same answer. Okay. Find the probability that the household has neither type of phone. Well, we actually use that to answer part C. That was 0.02. And then lastly, for part E, find the probability that the household has a cell phone only. So we want the probability that they have a cell phone, but not a landline. That would be 0.38. Okay. So continuing with these, let's see here. I'm not sure if I want to do that example necessarily. Well, we can go ahead and work through it. So, in 2012, fans at Arizona Diamondbacks home games would get 3 free tacos from Taco Bell if the Diamondbacks scored 6 or more runs. In the 2012 season, Diamondbacks won 41 out of their 81 home games and gave away free tacos in 30 of their 81 games. In 26 of the games, the Diamondbacks won and gave away free tacos. So we're going to let W be wins, T be free tacos, and let's think about choosing a Diamondbacks home game at random. So for part A, summarize this data in a two-way table. All right, this would be a good chance if you wanted to. Go ahead and pause the video, make your two-way table, and see if you get the same thing as I do. If you want to do that, I'm going to let the wins go across the top, so wins and wins complement, and then let free tacos and tacos complement go down the side. So if you want it to match up with mine exactly, that's how mine will be set up. If you want to go ahead and pause the video right now, feel free to do that, and then we'll get rocking and rolling. Okay, so it tells us that they won 41 out of their 81 home games, so 41 wins for the total, 81 total home games overall. Gave away free tacos in 30 of those games, so our total for free tacos should have been 30, and 26 games they did both. They had a win and scored 6 or more runs. All right, so filling in the rest of our table, 15 here, 51, 40 here, 4, and 36 goes in the middle. All right, for part B, find the probability that the Diamondbacks win, so probably that they win, or there are free tacos. So remember that this is where you have to use the general addition rule. So you got to take the probability that they win, which is 41 out of 81, plus the probability of tacos, so 30 out of 81, minus the probability of the 26 out of 81 where they had both. Really what you want to think about there when you're finding that probability is you're taking this column plus this row, but then you're subtracting away the overlap where it would have had to have happened twice. So that's kind of a good way to think about that general addition rule, is to think about it in terms of the table. So let's see, 30 plus 40 is 71, minus 26 is 45 out of 81, and I'll just leave it as a fraction. If you want to change it to a decimal, feel free. All right, for C, find the probability that the Diamondbacks win given that there are free tacos. Now, we haven't talked about this before, but this idea of given is the idea of what's called conditional probability. So when we say that we're given that there are free tacos, means we're only going to look at where we gave away free tacos. And so then the probability that they win, so probability that they win, given free tacos, so the notation we use for that is a vertical bar. So when bar T for taco is going to be the 26 out of 30 games where they won out of the games where they got free tacos. For part D, then, we're going to go a different direction. So this asks us to find what is the probability that they get free tacos given that they won. So now we're only going to look at the games where they won and look to see how many times did they get free tacos. So actually the 26 in the numerator stays the same, but now we're putting that out of the 41 games where they won, since we were told that they had won those games. Okay, so what we just described is this idea of what's called conditional probability. So, conditional probability is the probability that event B occurs given that event A has already occurred. Our formula for finding that is that we take probability of A and B divided by the probability of A. Okay, one last thing that I want us to talk about is going to be what's called a tree diagram. So we're just going to look at that real quick, and then we'll be done with this lesson. So Shannon hits the snooze bar on her alarm clock on 60% of school days. If she doesn't hit the snooze bar, there's a 0.9 probability that she makes it to class on time. However, if she hits the snooze bar, there's only a 0.7 probability that she makes it to class on time. Use a tree diagram to represent this situation. So there's two different things that are happening with Shannon. The first event is that she's either going to hit her snooze button or she's not going to hit her snooze button. So snooze and no snooze. All right, so the probability that she hits her snooze button says is 0.60. So then the probability that she doesn't hit snooze is 0.4. Now from each of those, we're going to then branch off again. So this is the idea of a tree diagram, is you've got these branches. So after she hits the snooze button, she's either going to be late to school or she's not going to be late to school. And that's going to be the same for each of the two scenarios. So it says if she doesn't hit the snooze bar, there's a 0.9 probability that she makes it to class on time. So no snooze bar and not late, 0.90. Which if you think about it, means that there's another 10% of the time where she is late. However, if she hits the snooze bar, there's only a 70% chance that she makes it to class on time, meaning that there's a 30% chance that she's late. Now, in addition to that, we're going to find the combined probabilities, which I list off to the right. To get your combined probabilities, you just take the two probabilities that get you to that point and multiply them together. So the probability that she hits the snooze bar and is late to class, multiply those together, is 0.18. Then do that going all the way down to 0.6 multiplied by 0.7. So the probability that she hits the snooze bar and is not late is 0.42. Continuing that, 0.4 multiplied by 0.1 is 0.04. And then 0.4 multiplied by 0.9 is 0.36. Okay, so for part B, on a randomly chosen day, what is the probability that Shannon is late to class? Well, to be late to class, there's two different ways that you could do that. There's late right here, and that was 18% of the time. And there's late right here, which is 4% of the time. So, total probability that she's late, add those together. So it looks like she's late about 22% of the time to class. So it looks like about once a week showing up late to class. All right, so for C, suppose that Shannon is late for school. What is the probability that she hit the snooze bar that morning? So we want to know what is the probability that she hit the snooze bar given that we know that she was late to school. Okay, so let's think about how we would use that formula for conditional probability. So what we want to know is what is the probability that she hit the snooze bar and is late, and we're going to divide that by the probability that she was late. Well, hey, got some good news for you. We already know one of these probabilities. The probability that she's late we found in part B, that was 0.22. And really, we've already found the top probability as well. probably that she hits the snooze bar and is late. So again, that was snooze bar and late. It is this 0.18. So really all we have to do is use the information we've already found, put that into our formula. So now we're taking 0.18 divided by 0.22, which is about 0.81, and the 81 will repeat, so I'll just put the bar over the top. All right, that's all I've got for you guys. Have a good rest of your day. If you've got any questions, let me know. Next week, if you're wanting to follow along through Unit 12, that'll just be some prep work for getting you ready for next year. In addition, I'll be getting your final review posted sometime next week, and then our final exam is 2 weeks from yesterday. And really, it's going to be anytime during that week. That's the week of May 18th through the 22nd. I'll have the final unlocked for you that entire week, so you'll have that entire week that you can hop on and take the final if you're choosing to do that. And if you guys have any questions, again, let me know. Have a good one. Talk to you next time.